There's a lot of confusion around oxidation reduction potential. When I teach classes, operators often ask, what is the sensor and what is it truly measuring? So today I want to do a little demonstration for you that hopefully clarify how the ORP sensor works and what you can do with it. So here I've got an ORP sensor set up just in some deionized water. You can see the value there is like positive 356, whatever. Well, we're gonna add something that's a reducing agent. So this product is mainly made up of sulfite compounds, metabisulfite and such. So what do you think happens if we add a reducing agent to this water? Well, let's find out. Add a little to it. Oh, that's all we need right there. We're gonna mix, get things stirring, and boom, negative ORP, and it went negative fast. So now we've created a solution that wants to donate electrons to anything that gets added to the solution, right? It's a reducing environment. All right, so we've got this strongly reduced solution now that we added the bisulfite to it. And now we're gonna oxidize it by adding bleach, right? Strong oxidant. So what do you think's gonna happen when we add bleach to this solution? We should see the ORP change. Look at that, in a very positive direction. Now we're going through the chemical reaction, so it's going to fluctuate a little bit. But ultimately what we just did is we stole a bunch of electrons from that solution. We oxidized that solution by hitting it with bleach. So bleach makes it positive, oxidation, negative like a bisulfite makes it go negative as a reductant. So what do we do with that? You know, in wastewater, especially if we're trying to do nutrient removal and we have anoxic or anaerobic zones or selectors, we can't use a DO probe to tell us anything about those environments. We need something that'll measure basically negative DO. And that's what ORP is really good at. It can measure when there's no oxygen because it's measuring the balance of the oxidants versus reductants in the water. So oxygen, strong oxidant, right? If you put a ORP probe in an aeration tank, we're going to get a higher, more positive value. If we take that same ORP probe, put it in an anoxic tank where there's no free oxygen and nitrate is present, we're going to see a much lower ORP. In fact, most anoxic zones, we want them to be between negative 100 and positive 100 millivolts. That tells us we have the right environment for the microbes, the heterotrophs, to perform denitrification. Now, if we go to an anaerobic zone, we're going to want to be less than negative 100 because we've got all that fermented stuff coming from the sewer that's very reduced and is a strong reductant. There's no oxygen, there's no nitrate, so there's not any big oxidants present to try to shift the ORP in a positive direction. So in an anaerobic zone, less than negative 100, and how low? It could be negative 400. It really depends on your plant and what you're trying to do in that anaerobic zone. So I hope that helps. What we want to see is we want to see ORP trend over time. That's why we put these probes in situ, and we just want to look and make sure that there's no abrupt changes to the ORP. If there is, that's an indication that the environment has changed and perhaps the microbes aren't going to do what we want them to do in the anaerobic or anoxic zone. Okay, so one last pro tip when it comes to ORP. Think of ORP, a sensor, like the bars on your cell phone, right? If you look and you see, oh, I've got 3 bars or I've got 2 bars, that tells you you've got the right environment to make a call or maybe try to download something. It doesn't tell you if I download it, how fast can I download it? Or if I need to upload something, how fast can I upload it? What are my speeds that are available? The bars don't tell you that, neither does ORP. It just tells you you have the right environment to do hopefully what you're trying to do, make a call, download something, etc. So that's why when it comes to ORP, we focus on ranges and we look at trends over time to see how that environment's changing and if it's changed enough that it might alter the biology that we're trying to achieve. So hopefully I've been able to help demystify the ORP measurement and its results to you a little bit. If you have comments or questions, put them down below and I will get back to you. Thanks so much for watching.